All right, so let's pick up where we left off. We were talking yesterday about, some vocabulary, solve, simplify, evaluate. You said when you solve an equation, you're finding the values of all the variables that satisfy the equation. Solve an inequality, you're finding all the values of the variables that solve the inequality, etc. Let's get rid of earbuds and stuff should be gone for this, please. We moved on and we wanted to talk about simplifying. Okay, simplifying is pretty straightforward. We're just trying to write things in the simplest possible form. When we're simplifying a numerical expression, we should get a single number out of it, right? And we were just kind of going through the steps of our order of operations steps that we're used to. And just to illustrate this point, real quick, you guys all know order of operations really well. You're great math students. It's second nature to you, but this is just so you kind of see the point of this. Let's take a really simple example. Like, what if I had something like 10 minus 3 times 4? How many operations are there in that expression? 2. Subtracting and multiplying, right? And if we didn't have an organized scheme about this, like, what if I subtracted first? I would end up getting 7 times 4 equals 28. If I multiply first, I get 10 minus 12 equals negative 2. Well, which is right? Negative 2, yeah, right. But you see that clearly we would go, we would get lots of different answers if we didn't strictly adhere to some order of operations, right? It's not like we just randomly picked this or it's just even a convention. Mathematically, it's the way it has to be, but we still have to follow it, right? Okay, so what about something like this then? If we go through our order of operations, first we do parentheses, which are grouping symbols, then we do exponents, then multiplication and division in equal footing, just from left to right, whatever we see first. First from left to right, same thing with addition and subtraction. We made in this case, what was our, P stands for grouping symbols, what was our grouping symbol? Absolute value, okay. So we got the absolute value of negative 8 is going to become a positive 8. The next thing we did was we took 4 cubed, we got down to the exponent step. Then we'd get down to step 3 would be multiply and divide. What would that look like? 64 minus, I have to do the 8 times 6 first. So I'd get 48 divided by 16, and then there'd be another step there, wouldn't there? There's another division we have to do. So we'd end up with 64 minus 48 divided by 16 is 3. So our final answer is, okay, good. So a couple points I want to make. Could we have made that a little simpler? Could we have combined some steps there logically? Yeah. Okay, what could you have done here that would have made this a little bit easier? I guess you could do that. You could say, okay, 48 divided by 16 and jumped right down to 3. But even if you didn't do that, there's something else that we could have and probably should have done at the same time. Okay, we could have done the exponent and the absolute value at the same time. Now, there's a really defensible reason for why we would do that without really even doing a lot of mental math. That's just something we could even do on paper and still would be a smart thing to do. Here's why. Look at this minus sign here. That minus sign is outside of any grouping symbols. Agree? So we can guarantee that that minus symbol is not going to be dealt with until the very last step, right? And notice there it is. This is the same minus sign that we started with, isn't it? Right? So if you know that you're not going to get down to the business of subtracting until the very last step, why not work simultaneously on the term to the left of that and the term to the right of that? Because they're not going to get confused, right? Does that make sense? So we could have really combined this stuff right here into one big step. It would have made sense to do. Okay? Get that? All right, let's do one more of these. How about something like this? So these are supposed to be brackets. Kind of got cut off there. So once again, we'll write down our order of operations tree. We're going in that direction, we're simplifying, right? Okay, so the P stands for grouping symbols. Do you see some grouping symbols there? Okay, what are they? You got brackets, absolute values in parentheses. There's some other ones that you didn't tell me. Okay, what about the dividing part implies some parentheses? Andrew, you got an idea? No? Top and the bottom, yeah. Anytime you've got more than one thing in a numerator or denominator, you got some stuff going on in a numerator or denominator, there are always going to be implied parentheses around the entire numerator and the entire denominator. So even though they're not there, there is an additional set of parentheses there and there that are implied. So what that boils down to, whenever you're solving a complicated, you're trying to simplify a complicated expression that involves a big fraction like that, your strategy is always the same. You're going to work on the top and the bottom separately. You're going to try to simplify the top as far as you can go, simplify the bottom as far as you can go, and then at the very end, you'll do that. You'll simplify the quotient. You'll divide it out, right? Okay, make sense? Are there any other instances that we haven't already looked at in the last example, or even in this one, where you could also get some implied parentheses, some grouping symbols that might be disguised?
The square root.
What do you mean by that? Say it again.
9.
Well, the 9, kind of, but you don't really need grouping symbols around the 9 because the 9 is just a 9. But anytime you have a function that involves some stuff inside the function, that's also an implied grouping. So for example, what if I had something like this? If I had, let's say, the square root of 9 plus 7 divided by 2. Okay, or let's not even do divisions. I don't want to, times 2. Let's do that. Where are the implied grouping symbols here? Inside the function, right? Inside the function, 9 plus 7, the very first thing we would do is combine 9 plus 7 to get 16, right? That makes sense? Okay. So that P, there's a lot more than meets the eye to that P. You talk about grouping stuff, okay? All right, so let's jump on to this one then. Now, another issue here. We've got all these parentheses. We've actually got 4 layers of parentheses on the top, if we include the implied parentheses around the entire numerator. So I've got the light gray ones, I've got the brackets, I've got the parentheses, and I've got the absolute value bars. Which one do we need to deal with first? Absolute value, how come? Okay, good, because we're going to work from the inside out. Those are the innermost grouping symbols, so we work from the inside out when we have nested grouping symbols. Okay? So step number 1 then. Step number 1 is going to be on the top. We're going to work inside, and so we're going to get let's do this all in one step. So I get the absolute value of what? -4. And what is the absolute value of -4? 4. So we'll combine a couple of small steps there. Okay, so there's step number 1 on the top. We might as well do a step number 1 on the bottom too. Step number 1 on the bottom, what's the first thing I'm going to do on the bottom? Exponent. Okay, so 3 cubed is 27, right? Okay, so there's step 1. Now what? What's the square root of 9? 3. Okay, so inside the next layer of grouping symbols, those are the parentheses, right? We've got to work inside there. Inside there, we've got the square root of 9 is just a 3, and what's 4 plus 3? Okay, so we could maybe combine a couple things there. Minus 7. Okay, make sense? Thanks, I should write that. That should be blue. That's that's the thing that got changed, right? And on the bottom, we're done. 3 minus 27 is negative 24. So there's the two things that changed. And now it's getting down there. 15 minus 7 is 8. Okay. Do I need those brackets? I really don't, do I? As long as, grouping symbols only make sense when you're grouping more than one thing. Grouping one thing is unnecessary. So we could get rid of the grouping symbols there. I mean, if you don't, it's not the end of the world. So those could be gone. And then, and that's supposed to be squared, right? Good. So then on the bottom, we've got negative, whoops. So our final answer looks like on the top, we've got 64. On the bottom, we've got negative 24. But while we're at it, what are we going to do with our negative sign? We don't want to leave it in the bottom. Could do what? Could move it up to the top. That works. What else could we do? Move it out front. Yeah, take your pick. I prefer to move it out front, but they both of those are reasonable options. But we don't want to leave it on the bottom. Okay, last step would be what? Simplify. How are we going to simplify that? Okay, find the greatest common factor of the top and the bottom. What's the biggest thing that divides into the top and the bottom? 8. Okay. So on the top, we get 8 times what? 8. On the bottom, we get 8 times 3. And then look what we can do. We can cancel those common factors. Okay. I'm going to make this point now, and I'll make it again many times. You can cancel common factors in algebra, but you cannot cancel common terms. So I can cancel those 8's because the 8's are things that are being multiplied by everything else on the top and everything else on the bottom, right? Here's probably the most common mistake that I see all the way up through even calculus. You see this sometimes. Like if I do something like this, if I have 3x over 3, I could cancel those 3's, couldn't I? Right? I could cancel those 3's because the 3 is being multiplied by everything else on the top. Okay, so that works. Those cancel, and the answer is x. How about this? What if I have 3x plus 6 over 3? Can I cancel those 3's? No. I can't. Okay, this I cannot do. I can't do this. That's not equal to x plus 6, right? How come? Because that 3 is not being multiplied by everything else on top. It's only being multiplied by one term on the top, right? Now what I could do is I could factor a 3 out of the top, couldn't I? If I factor a 3 out of the top, what am I left with? X plus 2, right? Good. Divided by 3, and I could cancel those. That's fair game. Because that 3 is being multiplied by everything else on the top. So it can cancel. Right? Get the idea? Okay. All right, so our final answer then is negative 8/3. Right? We got it. Okay. All right. Moving on. So I won't do any more of those. You get plenty of practice on that on the assignment. I think you guys are fine with that. The next section on the little handout, though, that you've got. Everybody's got this handout, order of operations. Everybody need it? Pass that back. Anybody else? Pass that one back. Anybody else? You good? I don't want that back. That's for you. It's not an assignment. It's not a worksheet. It's just for you to take some notes on if you want to. So the next section on there is, it's called evaluating expressions. So the directions here might be evaluate the expressions. I can't remember if we talked about this or not yesterday, but what does evaluate mean? I don't think we actually talked about it. That's one you may not be as familiar with. Everybody knew what simplify meant immediately, but evaluate's a little tougher, right? What does it mean when you say evaluate? The hint is right in the title. Value. To place a value on something outside of math can be difficult. I couldn't possibly put a value on Grayson Sam's because he's invaluable. It's too valuable to even think about, right? I mean, it's hard to do. There's a lot of things that go into a person, and you can't put a value on that, can you? It's hard to even put a value on a thing. If I want to put a value on a car, different people might assign different values to that car, right? Monetary value, let's say. But the value for a number is simple. What's the value of the number 11? 11. That's it, right? It's really simple. So when we evaluate an expression, we're going to enumerate the expression, right? We're going to plug a number in, plug a value in math is a number. We're going to plug a number in and simplify it. So for example, let's take number 10 here. If we want to evaluate the expression 3r minus 4s, when r equals 5 and s equals 2/3, what are we doing? We're plugging those values in for the variables and simplifying the result, right? That's all we do. So here's a good hint when you do this stuff. And I know this is really basic, but this is a good habit to get in for later on when things get tougher. Every place where we used to have a variable, I'm just going to open up a set of parentheses so I can plug a value in where that variable used to be, where the r used to be, right? So I'm opening up a set of parentheses for the r, which has a value of 5, and for the s, which has a value of 2/3. And then I just simplify that expression, right? No big deal, okay? And I'm not even, I think you guys, you'll be fine. I mean, if you're not, we'll deal with some questions on Tuesday. Okay, but I think you'll get this stuff and be okay. The last issue then is stuff like this. And I just want to make a point. Let's take the hardest one on here, and these are the easiest. The last section is evaluate these expressions, but this time they're not numerical expressions. They're algebraic expressions, meaning they have variables in them. Now, normally you'd think that you add variables to the mix and it makes things harder, right? And algebra is harder than pre-algebra because we add variables in algebra, right? But oftentimes when you're simplifying expressions, it's precisely the opposite. It's oftentimes easier to simplify things with variables because they're easier to work with, right? When we plug numbers in, if we plug a number in for x and that number is some kind of a, let's say it's a complicated thing. Maybe it's a quotient, it's a fraction involving radicals or something crazy like that, right? When I plug something like that in for x, that's not going to make things look easier. It's going to make things look harder, right? Because that's a number that's hard to deal with then. The variable is nice and clean and simple. It's just an x, right? So contrary to what you might expect, a lot of times it's easier to simplify with variables than without. And we'll see a classic example of that here if we take the hardest one. Let's look at number 20. If I want to simplify this, well, I'm going to follow, first of all, when I'm simplifying, I'm of course going to follow my order of operations. Okay, so step number 1 on problem 20 here, parentheses. So I have 2 sets of parentheses. Well, what can I do? Can I simplify the first set of parentheses? 2x plus y. You're right, how come? What do we call those? Terms that have common variables would be, you want to, and you know this, you always want to add what kind of terms? Like terms, yeah, right? So they're not like terms. They're unlike terms, so I can't combine them in either case. So that's a non-step, nothing to do. There are no exponents in this case. We get down to multiply and divide, so we're on this step. Well, in this case, I'm multiplying -8 times a quantity. When I have something in parentheses, it acts like, I call that a quantity in math, and it's just one thing, isn't it? So I'm multiplying -8 times this quantity. Those are both factors. Factors in math, and I'll say this many times, I want you to be used to the vocabulary. Factors are things that are being multiplied, and terms are things that are being added or subtracted. So I have 2 factors here. There's one and there's one, and they're being multiplied, right? So I'm going to multiply those. Well, how do I multiply -8 times that quantity? I distribute, don't I? So I end up with -16x minus 8y, and I'll do the same thing over here, won't I? I'll distribute the negative 3, and I'll get positive 15x plus, whoops, not 10, plus 6y. Everybody agree with that? Okay. And then finally, we get down to the last step, which is just add and subtract, and that's simple. Right now that I've got these nice clean variables, it's really easy to see which terms go with which terms. Negative 16x plus 15x is what? Negative x. Negative 8y plus negative 6, or plus positive 6y is? And there's my answer. Right? Make sense? Okay? I'm going to give you some time to work on this. So why don't you grab a Chromebook? You have a little time, don't you? 20 minutes. Pull up this assignment. Go ahead and get started. I threw a couple like challenging application word problems at the end that ought to make you think a little bit.